Good afternoon, everyone. My name is Pam Castens. I'm the Regional Project Manager for the South Atlantic Coastal Study, and I'd like to welcome everyone to our regularly scheduled quarterly webinar. The purpose of our meeting today is to provide you with an update on the status of our study as we move towards issuance of the draft report. It also provides us with an opportunity to highlight one of our technical products, and Dr. Drew Condon of our regional command center team will be talking in some detail today. We'll be showcasing the coastal hazard system products that are coming out and are actually available for your use as we speak. So we're going to get started in a few minutes. At this point, I'd like to turn the mic over to Lindsay Wilson, who's helping us facilitate this webinar, to talk a few moments about some housekeeping details. Lindsay?
Thank you, Pam. Yep, I will be helping facilitate today. So you can reach out to me at any time with technical issues or questions. I do want to go over a few logistical housekeeping items before we begin the presentation. You should have this control panel on the side of your screen, which has a spot for handouts. And this will have a PDF of the slides for today. It'll also have some additional information on the coastal hazard system. So you can access those and download them at any time. The attendees lines will be muted during the webinar, but questions and comments can be submitted through this question box at any point during the presentation. And then we'll do our best to kind of bring them into discussion at one of the 3 Q&A time slots that we have set up. We also want to find out a little bit more about who we have on the line today. So if you could please now use the question box to introduce yourself with both your name and the group you represent. That would be really great for our records. And we also, while we're doing that, we're going to do a little poll so that we can kind of get a quick sense of who we have on the line. So we will open up the poll, and you can also introduce yourself via the question box. So give me 1 second and I will open up the poll. Okay, so you should be seeing the poll open on your screen. And if you don't fall into one of these categories, it's another reason that we are collecting your introductions in the question box too, so that we have a full picture of who we have. So I'll give it another few moments for people to do both of these tasks. And then we can view the results of the poll. All right, I'll give it another couple seconds for the poll, and then I'll open it up here. Okay. So now you should be able to see the results of the poll. It looks like we've got mostly state and local agencies and federal agencies, some non-governmental agencies, and some academia. All right, I'm going to close that. And I will hand it back over to Pam.
All right, thank you, Lindsay. And again, on behalf of the SACS regional team, we really do appreciate your participation and your continued interest in the study. We usually like to kick off these webinars just with a reminder, a refresher on our shared vision statement. This shared vision statement essentially sets the metric against which success of the overall study is assessed when the draft and the final reports are processed. So the statement is a product, was a collaborative product that was developed at study initiation with you all as stakeholders and partners through a series of meetings and workshops. So again, we appreciate your input as we use this shared vision statement as a guide for our study execution and study activities, again, through development of our final report. Next slide, please. The flow of information, the overall agenda for the webinar today, we try to keep these somewhat consistent. I'm just going to hit very quickly, give you an overview on where we are in overall study execution. We recognize that there's a lot of interest in the coastal hazard system, so we're going to get into that technical discussion in very short order. I do want to mention that when Dr. Condon moves through his presentation on the coastal hazard system, would like to try to keep this webinar as interactive as possible. He will be pausing at certain points during his presentation to open the floor to questions. As Lindsay indicated, please put your questions, submit your questions online here. And then when Dr. Condon pauses, we'll take those questions in the order that they've come in as he moves through his presentation. Before we wrap up, I'll just kind of hit the highlights on what our next steps are for you in terms of the study. And if you've got any overall questions about the study or what comes next, we'll provide you with an opportunity to ask those questions before we wrap up. Next slide, please. These are our points of contact for you. Again, we like to ensure that we refresh this with every webinar. You can see the folks on our command center team over on the left and our district project managers on the right. If you have a particular interest in anything that's going on the study relative to any particular state or territory, please reach out either to myself or to the respective project manager. The actual contact information for our team members can be found on the final slide in this presentation. And because we're going to be talking in some detail about the coastal hazard system, we'll also be providing you with the points of contact for the engineering team members that are working to apply the coastal hazard system in the SACS products throughout the entire study area. Next slide, please. So this is just an overview of where we are in the overall 4-year study timeline. We started the study in August of 2018, so we'll be wrapped up with approval of the final report in August of 2022. So we're already staring down the neck of our final year as far as the study goes. The tan bar that you see, the vertical tan bar, puts us right here where we are in July of 2021. You can see that we've got a lot of work that's under our belts. Many technical products that are in the final stages of policy and legal checks before posting those to the SACS webpage and making those available for you to apply in real time now. We are currently in the process of going through district quality control review of the draft report and all of the state and territory appendices. We'll be incorporating review comments, making some final edits, and then putting that report out onto the street for you all to take a look at and provide comments and feedback to us in October of this year. And then again, we'll be working with that feedback to finalize that report for submittal in August of next year. Next slide, please. So these this is a snapshot essentially of all of the South Atlantic Coastal Study key products. Circled here, of course, is the coastal hazard system. This is what we're going to be talking about today. Next up, we're on our next quarterly webinar. We'll mention that a little bit towards the end of this presentation. We will be showcasing the Tier 2 economic risk assessment. So with that, I'd like to turn the mic over to Dr. Condon to start the presentation on the coastal hazard system. Drew?
Okay, thank you, Pam, and thank you everyone for attending this afternoon. Today I'm going to do my best to kind of give you an overview and a walkthrough on the coastal hazard system, or I'll probably refer to it as CHS quite a bit. One thing we do have is looking at the chat box and the questions is we do have a very diverse audience. So I'll do my best to not get too much into the technical weeds of the CHS, but also provide that appropriate detail to those that that are looking for it. So I'll start off with an overview of the CHS, including some background information, and get into the CHS development as part of SACS. And this will probably be the more technical portion of the talk, but then I'll get into an overview of the products and the data and how to obtain it, along with potential uses. I should mention right at the beginning that the CHS is developed at our Coastal Hydraulics Lab at our Engineering Research and Development Center. There's an entire team, there's about a dozen people working on this effort there, headed by Norberto Nadal. And they are kind of the true gurus of the CHS, but I'll do my best in presenting it to everyone here today. So if we jump to the next slide, please. Okay, so just some background information. What is the Coastal Hazard System? So the Coastal Hazard System is it's a national scale effort for the quantification of coastal storm hazards and distribution of probabilistic coastal hazard analysis results and statistics. So, and I'll kind of break that down a little bit. The main components of the CHS include this PCHA, or the probabilistic coastal hazard analysis. And again, I'll probably refer to that quite a bit in the talk too. There's a couple acronyms to learn along the way. A data repository, a web tool for easy access to the results, and a website containing documentation and metadata. So the PCHA, as I mentioned, I have a slide or two on that later on, but just as a quick overview, it's this innovative framework that integrates a characterization of the regional storm climatology, advanced joint probability analysis, some high-resolution atmospheric and hydrodynamic numerical modeling, and some cutting-edge machine learning techniques and meta models to really describe, probabilistically describe the hazard. So data distributed through the CHS include the numerical model output and hazard curves for storm surge, waves, currents, and wind fields associated with tropical and extratropical cyclones. And these hazard curves represent the magnitude of the hazards as a function of their annual exceedance frequency, or also oftentimes we'll say annual exceedance probability, along with corresponding uncertainties in the data. So the CHS really provides a centralized location for all of this data for a number of applications, and it's out there and available to the public, and we'll kind of walk through that later on. Next slide, please. Just quickly to kind of hit on the goals of the CHS, as they're written here, it's the long-term storage and public access to measured and high-fidelity modeled coastal storm data. So, to allow users to easily get into the data, download data, and use it for their own applications. The easily accessible data and contextual data products and tools to support federal decision making, although these tools, are also widely being used, at the local level or at other levels outside of just the federal level. And really it is, as I kind of mentioned, just storing the data and making the data accessible for, internal and external use to help support our mission and the missions of, other municipalities and areas. So if we jump to the next slide, I'll just give you a quick overview on some of the studies that have taken place. So the Coastal Hazard System is not unique to SACS. There have been some past studies, and they really kind of improve upon the methodology as they go. One of the important aspects of the Coastal Hazard System is the regional approach. The PCHA, or the Probabilistic Coastal Hazard Analysis, is similar in methodology to some other studies, including many FEMA studies, although there are some differences, and I'll touch on those briefly. But one of the big differences is that it's conducted over a much larger study area, and by a consistent team. The team at ERDC has done this, as you see on the screen, for a number of studies, as opposed to contractors that may have a small slice of coast, and so you lose out on some of that consistency in the approach and in the results. Also, this process, as I mentioned, is continually evolving as new research leads to efficiencies and improvements. So listed here are the previous studies, including 2 legacy studies in italics and our current study highlighted in bold. So data from these studies are available on the the CHS website. Some of you may be familiar with some of these other studies, including the North Atlantic Coast study, which was kind of the immediate predecessor to our current study with SACS. Next slide, please. Okay, so for SACS specifically, I wanted to get into the different regions that were modeled. And on this screen, you kind of see the master tracks for all of the CHS studies, the master storm tracks, and we'll talk about that in a little bit. But for SACS, we have 3 different regions that were studied. We have a Southeast Atlantic model, a Northern Gulf of Mexico model, and a Puerto Rico USVI model, or kind of a Caribbean basin model. And each region has a separate storm suite and model and setup. In addition, each basin, not only were present day water levels modeled, but also 2 future sea level scenarios. So these scenarios kind of correspond with the basin-wide average for each of the basins, based on the USACE intermediate and high sea level curves, going out about 100 years to about 2120 or so. So that it varies from basin to basin, but roughly corresponds to about 2.5 and 7 feet of sea level rise for those 2 additional scenarios. One thing to note on this slide, just with all these tracks, is at this point, the team has really pretty much has the Gulf of Mexico and Atlantic coast well studied and well modeled, and the parameter space is very well represented with CHS at this point, with SACS kind of being the concluding step in that. Next slide, please. Okay, so this is just kind of an overview of the workflow for the CHS. The details here have been presented and published in various forms by the team at the Coastal Hydraulics Lab. So there are much more detailed presentations and papers out there. I'll kind of just give a quick walkthrough. And really the process starts with efficient storm sampling. So in this step, the historic climatology is examined in terms of the storm intensity, or the central pressure deficit, the size of the storm, the speed of the storm, the translational speed of the storm, I should say, the storm direction, and the landfall location. So the likely probabilistic space for these variables is defined, and synthetic storms are defined to cover it. And so as a set of synthetic storms is developed, and each one is assigned a weight or a probability based on the climatology. And while that work is being done, if we jump down kind of to the lower left, There's a separate group, a modeling group, that is developing very detailed regional meshes and performing validation studies for a coupled AdCirc ST-Wave model based on wind and pressure fields that come from the planetary boundary layer model in deep water waves from WaveWatch 3. So as they kind of calibrate and validate this model system, the other teams develop in the synthetic storms, and once everything's validated, ready to go, all the synthetic storms are then modeled under current day and future sea level conditions. The model results are then combined with the joint probability or the weights, so to speak, developed earlier to provide annual exceedance probabilities and confidence levels. So finally, the last step is all that data is hosted to the CHS website for easy access and viewing. I'll get in at the end of the talk. We'll kind of go through the website and take a look at the types of data that's available. You know, as I mentioned at the start of this slide, there's a lot of details that I kind of maybe glossed over a little bit. So, you know, if you're interested in those, there are, you know, references I can point out to you, or, you know, we can talk more about those. If we go to the next slide on the, oh, actually, yeah, question. Sorry about that. I forgot we have a question slide here.
We do have one question so far. What sea level rise projections were utilized for SACS? NOAA Intermediate or NOAA High?
For the coastal hazard system development, we utilized the USACE, or the Corps of Engineers intermediate curve, our basin-wide average. So, you know, we're modeling an entire basin, so we can't really pick one gauge, but average of a number of gauges within that basin for the intermediate and for the high curve.
Great, thank you. And that so far is all we have. So I might suggest we keep going with the presentation, and if people do have more questions, we can get to them in the next question round.
Sounds good. Okay, so these next few slides, I wanted to just give a quick overview of the modeling setup for each of our three study domains. And you'll see the setup of the slides are fairly similar, so I'll probably repeat myself a little bit. But first slide is the Puerto Rico and USVI domain. As part of the modeling that was done, a series of nested WaveWatch 3 models were used for the deep water waves to provide the wave boundary conditions. Those transition down from about 1/4 of a degree to 0.02 degree resolution. And then we had 25 ST-Wave or nearshore wave model domains throughout the region, with resolution between about 150 and 200 meters. And you can see those ST-Wave domains in the middle, the bottom middle plot. And, you know, one thing to note for this area, this is somewhat a unique environment, same with the Florida Keys, in terms of the wave modeling, using this wave model, the ST-Wave model, is that, you know, we can force the boundary on different sides here. If you look at St. Croix, for example, there's the northern, eastern, western, and southern boundary for the same domain that all can have the force applied. So there's some nuance into including the correct or the most appropriate wave force in the setup of the models. The hydrodynamics are run on a AdCirc mesh. For those interested in the numbers on it, it's a 2.86 million node or 5.64 million element AdCirc mesh with a minimum resolution of about 30 meters. In the nearshore areas, that resolution ranges from about 30 to 100 meters or so, with the minimum being 30. And for this domain, data was saved at almost 15,000 save point locations throughout the domain. So those are the points that you can go into the CHS website and access data at. Validation was performed for some historical storms, hurricanes George, Irene, Irma, and Maria. And the details of the validation report can be found in a Coastal Hydraulics Lab letter report that has been published for this domain, so that is available. Next slide, please. Okay, so again, similar slide, we're looking at the Southeast Atlantic domain, which covers from the Virginia-North Carolina border through the Florida Keys. It is a similar setup with multiple nets of WaveWatch 3 providing deep water waves to 14 different ST wave domains. The ST wave models are dynamically coupled with the AdCirc model. Again, this is a much larger AdCirc mesh. It features 6.2 million nodes, 12.3 million elements, and a minimum resolution of about 30 meters as well. One thing to note, so throughout this domain, there are almost 35,000 save points where data is recorded and available. And the validation letter report for this study is still under review, I should say the final stages of review, but the validation was performed for the 7 historical storms listed here, ranging from Hugo in '89 all the way up to Florence in 2018. Also, I should note on this, for this domain, both tropical and extratropical storms are modeled. I failed to mention on the previous domain. For Puerto Rico USVI, only tropical storms were modeled here. A subset of extratropical storms are also part of the modeling and the results, or incorporated into the results here. Okay, next slide, please. Okay, and finally, the third study domain is the Gulf of Mexico domain. And again, it's kind of the same type, same workflow, I should say, with WaveWatch 3 model, providing waves to, in this case, 13 ST wave domains. Those are all dynamically coupled with an even larger AdCirc model. 7.8 million node, 15.6 million element AdCirc model. Like the Southeast Atlantic, both tropical and extratropical storms are modeled, and the results here are stored at over 38,000 save point locations. And similar to the Southeast Atlantic, the validation is still, or the write-up for that is still under review. Although I should mention, for all these studies, or for all these domains, there was a technical oversight committee that kind of worked with the team throughout, and they've also given their blessing and write-off on the validation and calibration of all these models. So the letter report is under review at ERDC, but the validation has been blessed by the oversight committee. And here we have 8 historical storms that were modeled, going from Opal in '95 to most recent Michael in 2018. Okay, so the next slide, please. Okay, and the next 2 slides, I'm going to talk about the probabilistic coastal hazard analysis, and these are probably the 2 most technical slides here, so I'll do my best to not bore you with the details. But you know, we've looked at the 3 domains, discussed the model in a little bit, but here I wanted to provide some details on the PCHA. So one of the first questions we get is, why do we use synthetic storms? And we can see in this example for Hurricane Michael that the true hazard is usually underrepresented in the historical record. So here, if we look at Mexico Beach, Florida, prior to Hurricane Michael, you know, in the 176-year record, we have 19 hurricanes within 50 kilometers, and only 3 of those were Category 3 storms. And then Michael comes along, Category 5 at landfall, and you know, completely alters the historical record and any analysis, extreme value analysis that might have been done to develop annual exceedance probabilities in that for this region. So with that, you know, we turn to synthetic storms that are meant to cover the probability space. So the method of choice has been the joint probability method, or joint probability method with optimal sampling. And the probabilistic coastal hazard analysis is very similar to the JPMOS, with some enhancements that eliminate some of or account for some of the codependencies of the variables on each other. So rather than saying all variables are independent of each other, it accounts for, you know, intensity correlated with radius to maximum winds or something like that. So with this method, the standard tropical cyclone forcing parameters are defined and used to cover the probability space. So these parameters you see listed here are the track position, the angle, the intensity, the size, and the translational speed of the storm. So a combination of these parameters is used to cover the probability space through a number of synthetic storms. If we go to the next slide, it kind of gives a kind of walkthrough of the approach here and the basic elements of the probabilistic coastal hazard analysis. So, you know, based on the historical climatology, the frequency of the tropical cyclones occurrence at a location is defined. Forcing parameters discussed on the previous slide are then fitted to probability distributions. Through optimal selection techniques, there's a set of synthetic storms are developed, and their weights or their probabilities are defined, and then everything is modeled in the high fidelity coupled modeling system. And finally, there's a integration of the response, and the uncertainty is undertaken to produce the hazard curve information. So there's a lot of detail and a lot of math that goes into this that I kind of skipped over. As I mentioned, there's a number of publications on this. Most recent, I think, just came out earlier, I think last year, 2020, discussing in detail the PCHA. And so, you know, for those interested in that information, that data is out there and available. We can go to the next slide. Okay, so with that in mind, I just wanted to give an overview of the final storm suites that were developed and kind of a breakdown of the discretization of the variables and the range of the variables used. So for Puerto Rico and USVI, a total of 300 storms were modeled. And one of the things I kind of skipped over in the talk is I didn't want, again, it gets very technical, but part of the PCHA, there is some machine learning techniques that have been incorporated into it that develop an augmented storm suite basically based on the responses of the modeled storms. So the ITC is this initial tropical cyclone suite that includes 300 storms that actually are numerically modeled. And then through machine learning techniques, there's an augmented suite that comes up with about 348,000. So it's a much finer discretization of the response, and it helps the kind of knock down the uncertainty and provide a little more confidence in the results. For the Southeast Atlantic, there's a total of 1,060 tropical storms that are modeled, and augmented storm suite of over 1 million, or over 1,160,000 responses that were developed. And for the Gulf of Mexico, there's 1,085 storms modeled and an augmented suite of over 1.25 million responses developed. So the data on the CHS site currently is the modeled results of the initial suite, but the augmented suite is used in the development of the annual exceedance probabilities or annual exceedance frequency data that's there. But the time series data is unique to just the modeled results. And again, we'll kind of walk through that available data in a few slides. Next slide, please. Okay, finally, for each of these study regions or study domains, there is a technical report that is being developed. All of these are still in preparation and they'll be released kind of in this order, with the Puerto Rico USVI one coming up first. But yeah, again, the details, a lot of the stuff I mentioned, I said I skipped over or glossed over quickly. That will be included in these technical reports. And if you're interested in those, you can reach out to me or Norberto, and once they're published, we can make sure you get a look at them. Okay, next slide.
All right, we do have some questions coming in now. I think we'll start with, there are a couple different questions about the sea level rise scenarios following up on the last question. So one of them was related to the NAAQS as well. And they were under the impression that both NAAQS and SACS used +1, +2, and +3 feet as the sea level rise values. And so trying to understand the use of the Army Corps scenarios in SACS and in coastal hazard system.
Okay. I'm trying to think about NAAQS. I believe NAAQS only used one at least modeled one sea level change scenario. And it was a plus, plus a standard value. I'm trying to think. I think it was +3, but I can look into that. But the reasoning for at least for SACS, I can speak specifically to. I guess the reason we use the scenarios is, well, I guess one, to tie into all the work in our climate COP and our sea level change estimates. We worked very much with the climate group here at USACE in developing these future scenarios, as well as just discussions on kind of ways to or the best ways to, I guess, bookend future sea level rise, so that by using the high estimate, much higher than what was modeled in NAAQS, 100 years out, approximately 7 feet or a little over 7 feet in some of the basins. We kind of bookend the expected response, and that way we can use that to, kind of look at intermediate values, those that weren't modeled but kind of fall in the range between present day water level, 2.5 feet, and the high, sea level change scenario. So I hope that answers the question.
And along this might be kind of answered already in that, but just a little more elaboration on why the NOAA sea level rise projections were not utilized.
Yeah, so I guess for our use of the data, our guidance is kind of bound to the USACE projections. The NOAA projections outside of the NOAA high fall within that range. Current observations, we do use our sea level tracker tool, which if you're not familiar with, it's a neat tool that's available through our climate group. We do evaluate that and kind of look at how sea level trends are in a given area. Most of the trends seem to be, between at least the 19-year moving average, kind of a longer period moving average is between, our intermediate, or it's not exceeding our high curve, let's put it that way. It's between either our low to our intermediate or just above the intermediate curve. So, it's kind of a combination of our guidance. For our projects, we're bound to our USACE curves, but also looking at, the current state based on that sea level tracker tool and other tools and seeing, what the current trends are.
Great, thank you. We also have one, they're curious about for future scenarios about boundary conditions used with the higher sea level rise scenarios, especially initial groundwater levels and inland boundaries of the model domain.
Yeah, that's a good question. So I guess, especially for some of these higher sea level change scenarios, there's going to be questions like that, and there's also questions about what future what the future land cover situation looks like, so to speak, future roughness, bottom roughness, and things like that are part of the model. So the way these are modeled is really as just a increase in initial water level that's uniform across the domain. And then that's kind of allowed to run a little bit, make sure the model is stable, and then the synthetic storms are run on top of it. So really, I guess the uncertainty in the results probably increase the further inland you get, the further away from the coast you get. One of the, and I'll get into the types of data here in a few slides, but one of the key parts or goals of the CHS and the way that we use it a lot internally is to drive higher resolution or more detailed project specific models. So we'll take the data kind of at an offshore boundary or a number of boundary points and use that to drive the more specific project scale models. I guess the downfall of the regional approach here is that, it's too large of a study area given the time and budget and all that to incorporate all the, potential local effects of, increased sea level throughout the whole domain. So it's, as I said, it's just kind of that initial water level and run that way.
And one person was asking, this is specifically for South Carolina, but how far inland the data will be reported for.
We can look at that. If the live demo works, we can look at that in a few slides here.
Yep.
If it doesn't, I can. I don't know specific. It goes fairly far inland, but I don't remember the specifics offhand. So, but yeah, I can follow up with that specific question if the live demo doesn't go as planned.
Yep, and we have the asker's information if we need to follow up with an email.
Okay, great.
Another question about the resolution. Is there better than 30-meter resolution when close to the shore?
No, so the 30 meters, the maximum resolution. And again, kind of going back, I guess, 2 questions. One of the things I mentioned was, this model again is a regional approach. So, and in many cases, you may desire a higher resolution than 30 meters. This really provides the boundary conditions for those additional studies that can be undertaken at the higher resolution. But given the size of the domain and already, the size of these AdSork meshes that are being run, it's a whole lot of super computing power that's needed to run these simulations. Not to mention there's 1,000+ simulations per sea level change scenario. So there's a whole lot of computing hours that went into the development of this data.
And following up with the resolution question, do you happen to know if there's going to be a resolution increase in the near future?
I don't believe so. Probably not, no. Again, it would be, any resolution increase would be local users, taking this data and running their own models at a higher resolution, forced by CHS results.
Okay. And another question, there appears to be 3 different AEF values for per save point, and no sea level rise or tides. Why do they differ?
I'm not sure I completely understand the question. For a given save point, there's a number of AEF values. Okay. I'm trying to think. Perhaps you're looking at, there's different confidence levels that are reported out. So for a given, say you're looking at the 1%, 100-year, so to speak, AEF value, there's a best estimate, which is kind of your mean, your 50%, and then there's different confidence levels that are reported out as well. So in our design, we typically will use the best estimate, but we also report out a 90% confidence level, confidence limit. So that's probably what you're seeing for a given AEP or AEF value.
Okay, thank you. One person asked, they see the Great Lakes FEMA study is included. Will future FEMA coastal studies be included as well?
So that FEMA study was done by the ERDIC team, so it's included. And I have the last slide kind of talks about some of the coordination, but the 2 groups, the FEMA group and our group at ERDIC or CHL, they meet regularly. Every other week they meet, and they're talking studies, talking advancements, reviewing each other's work, and all that. So I don't know if any FEMA study data will specifically be hosted on the CHS website, but there is coordination amongst the groups.
Okay. I'll do just like 2 more questions maybe here, and then we'll go back to slides. One person was wondering if there's any kind of table that outlines the sea level rise values that were applied. And then following up, did you assess how future storms may change from changing climate conditions?
The tables I didn't include in the slide, but if again, I can send those out specifically, or I can send those out. And they're included in the tech reports that are being written that were on the previous slide, but it might be a little bit given our review process and publishing process until those are published. So I can provide those values. The storms, no. So and again, this kind of gets back to our guidance. At this point, our guidance does not specifically, well, it specifically calls out that we are not looking at changes in storm intensity or frequency. Basically, because there's still quite a bit of, I guess, discrepancy or back and forth in the literature regarding, what that future climate may look like. But one of the unique things about kind of this methodology and the way it's done is the parameter space. So when they develop all these synthetic storms and they vary, for example, the intensity along those storms, it covers a very wide range. So that discretization that we showed a few slides back, there's some very intense storms are covered that would be indicative of future climate. So really, they wouldn't have to go back and run the numerical model again for future storms, since those storm conditions have already been modeled. But what they would have to do is kind of adjust the probability or the weighting of those storms. So it wouldn't be as involved of a process as having to start the study over again for future storms. It would really be adjustments into the probabilistic description of those variables, and then the rerunning the analysis to get to the AEP or AEF values after that.
Great, thank you. I think there's still some questions coming in, but I think maybe we should go ahead and get through the slides and then come back for our final questions. We can circle back to these.
Sounds good. Okay, so types of data. Shown here, I have types of data that are part of the CHS workflow. So the storm conditions currently are not directly available as part of CHS, although the storm combinations that populate the storm suite are available in the technical reports and the appendices there. But the results in the red box are kind of what I'll focus on. These are what is available or will be available as part of the CHS. The model results for both the hydrodynamic and wave model is available. So this includes the water elevation, the wind, current, atmospheric pressure from the ADCIRC model, along with the wave height, period, and direction from the ST wave model. And then there's a number of statistical data that's available. So I've talked about the average recurrence interval information, but also the storm recurrence rate information is available, along with nonlinear residuals due to sea level change and astronomical tide. Some of this data is still being populated. Some of it's already available. So the data repository is kind of continually being updated with all this information. And finally, on the right, observational is planned to be added to the CHS in the future. Currently, they're looking for funding to do that. So you would also, have your NOAA and your NDVC wave data information available. At present, I believe they just have links to that information, so you can, go right to the NOAA and NDVC sites. But hopefully, in the future, that information may also be available all in kind of one site. Okay, next slide. Or actually, I think.
Oh yes, I will transition the presenter role to you, Drew.
All right. Okay, do you see my slide or my screen?
Yep, we can see the GeoPortal.
All right, excellent. So they're on what I'm going to do is just kind of walk through the next few slides or next few steps here on how to access the data. And you can access the CHS website either directly through ERDC, but we have also added a link to our GeoPortal. If you kind of go up to the up top right, more coastal hazard system, and there's a direct link right to the CHS site. Let's see if this, and the site's, there's a lot of data on it, so sometimes it's a little slow loading. So if this doesn't want to, I'll jump, kind of walk through. So this is what the CHS site directly looks like. And the link, I guess we can provide that. I think I have it on kind of backup slides, but I can provide that as well. They're working on some of these other parameters. So if you visited the site, I should mention, if you visited the site for NAAQS data or other studies, it looked a lot different. So this is version 2.0, which was just released for SACS. Basically, the SACS data set is much bigger than they've dealt with in the past. They had to do a lot of work on the back end of the site. So they've updated it with this version 2.0. So currently you can search for data by study. In the future, location and storm will give you other options. So if you click on study, hopefully it goes. Give it a sec. If it's taking a sec to load, so basically we'll give you to this next page where you log in. And this, as of now, you can log in as a guest user. I believe they are working on ways to set up user accounts for this. So, you can kind of track what data you're looking for in that. So if we log in as a guest user, there'll be a disclaimer that pops up. Can close that out, and we basically see the study areas, or the areas where data is currently available. We'll go and select a study. In this case, we'll do South Atlantic coastal study. Sometimes this can be a little slow. I guess we had a question about South Carolina. So if we select here, we're selecting our Southeast Atlantic study. If we apply filter, hopefully this goes somewhat quick. These polygons basically depict where data is available. If you scroll in close, to a given area, it will eventually turn into save point locations. So each of these dots. So here's, probably the furthest inland extent here in South Carolina of save point location, of save point data, I should say. What I was going to show, and kind of to tie back to my slides, I picked a save point in Puerto Rico. I don't know if we need to, I guess I could have just used that save point in South Carolina. But anyway, so this is the navigation. Actually, there was one other thing I wanted to show. So let me zoom into the save point. Apply filter. Give it a sec. All right, so yeah, this is the save point I use in the slides when I jump back. So you can select a save point. It will give you an idea of what data is available, give you the save point ID, ST wave data, the annual exceedance frequency data. So we have, again, the 10, 16, 84, 90 confidence limit. We also have the best estimate data, along with conditional annual exceedance probability. So this is for some of the wave parameter data. It's computed both independent of still water level and with dependency on still water level. So if we go to our, basically you can select one of these tools to select a number of save points. I'm interested in this save point here. It will pop up and I can select the save point I'm interested and then go to downloads to get the data. And we can see some of the data that's available here. And can I move this? No, I can't. I had only selected the base condition, so this doesn't have the additional you can still see my screen over here on the left in this panel. There's base conditions and there's base conditions plus tides, which is all the validation storms. There's base conditions plus sea level change 1 and base conditions plus sea level change 2. So I had only selected the base conditions, but if I had selected those other ones, those sea level change scenarios would also be available here. And the types of data, we have time series, we have peak data, and then we have the annual exceedance frequencies. So if I'm interested in, water level data, I can, this will be, do this. I can download it as an H5 file, a CSV file, or it's both. For ease of looking at, I'll download it as a CSV, click OK, and let me jump to, eventually it will download, and if you open it up, you'll have something like this. It will be a zip file. So if I'm interested, and this is the fun part, you get to click through folder upon folder. If I'm interested in just the annual exceedance frequency curves for still water level, I can, something like this will be available, which again, you can do the same thing for waves. It gives me a best estimate, kind of the confidence bands here for the curve. If I, let me go back up. To CSV, this again will give me my peaks, my time series data, and I'll walk through this in the presentation, but this will kind of let me go through it a little quicker. So for example, here's time series from AdCirc. Here's our storm ID. So for this first storm, gives you all the time series. It gives you the, let me scroll back up. Sorry about that. It gives me the date time, the atmospheric pressure, the water elevation, the average depth velocity, east-west average wind velocities, east-west, and then same with north-south. For the save point, this file, the CSV file, if I go down, you'll see all 300 storms are listed here sequentially. So you have all that data available. This is the type of data, and I'll show this in a couple slides, but this is the type of data you could use to drive, boundary conditions for a more high resolution model if you're interested in that. And just quickly, the peaks data is the same idea, but here we have each individual storm. So this is only 300 entries for this study domain, gives us the peak water level. And then same with, gives you these other variables. Usually we're interested in the water level, but it does give us all these other values. And also, just quickly, the AEF data. Let me see. Oh, I already have that one open. Again, so this gives us the annual exceedance frequency values for our best estimate are 10, 16, 84, 90% confidence limits, and our AEF annual exceedance frequency value. So, if we're interested in a 100-year event, here's our best estimate, and along with that, this may answer that question. Previously, we have our 10% confidence limit all the way up to our 90% confidence limit. So I think that covers what I wanted to show with the demo. I think we can jump back to the slides.
All right.
Okay, so and a lot of this I covered in the demo, but again, so the peaks data, we kind of looked at that. On the bottom, I just made some, for the same save points, some simple plots of the AdSork peak water level and the ST wave peak wave height for the area. You can kind of see how that varies by synthetic storm for this region of Ocean Park near San Juan, Puerto Rico. And this data, as I mentioned, tried to show in the demo, it is available for different sea level change scenarios. And it's also available for the historical storms under the base sea level change. Next slide. The time series again, so these are again available for, I guess in addition to the peak, we have the time series here. Again, for historical storms being the validation storm. So this example on the bottom is Hurricane Maria. And then again, the same variables are available here. So I think that kind of covers that. I talked about most of this in the demo. Next slide. Yes, and finally, the annual exceedance frequency curves and the stats. Again, the spreadsheet that we looked at is there, and the curves themselves, if you just want, it's very convenient to just have a direct plot of the values, especially, to stick in a report or something like that. So those plots are also available. And, this is available for both current and the 2 future sea level change scenarios. Next slide. Okay, so next few slides, I'll probably go through kind of quick. I just wanted to show some example plots, kind of using some of this data, but there's almost an endless number of analyses of plots you can come up with. So here, looking at the Caribbean Basin, here's the 1% annual exceedance probability. Still water levels are on the left. The change in wave height between the high sea level change scenario in the present day, and the change in wave energy between the intermediate sea level change scenario in the present day. You can kind of see the variation. We see, in this region, we have relatively low still water levels, especially compared to other regions. And we can kind of see the variation across the territories. One thing that's kind of notable is the increase in wave heights between our present day and future sea level change scenarios. We have nearly 1 meter increase across the study area in the nearshore environment. So, and going along with that is the increase in wave energy that will reach the coast. So, these of course have lots of future implications to erosion and engineering design and design of engineering features in the future. I think we can go next for the Southeast Atlantic. Again, so these are similar type plots. Still water levels on the left, 1% AEP, 1% AEP wave heights here in the middle, and change in wave energy between intermediate and high on the right. And it's a good, again, the regional overview. You can kind of see the regional trends of the still water levels with, highest values from about northeast Florida up through kind of central North Carolina, right before you get out to the Outer Banks. The wave height variation with the highest wave heights up off the North Carolina coast, and some of that deeper water right off the Outer Banks. And also, again, the increase in wave energy that is expected under these future sea level change scenarios. And final plot will be for the Gulf of Mexico. Same idea. I don't want to spend too much time on these. Here we see the kind of the sea level or still water level changes, or not changes, but values under current day sea level, with, again, high values along the Mississippi coast and in the Big Bend region of Florida. Upper right, we see the change in the 1% AEP wave height, which shows up to about a 1.5 meter increases in wave height. Lower right, and that's between the high sea level change scenario in present day, and the lower right, which shows kind of the percent change in wave energy between the intermediate sea level change in the present day. So like all the other areas we've looked at, and we are expecting with sea level change, of course, there'll be kind of for a given location an increase in wave energy that's reaching the coast. Next slide, please. Okay, and just a few more slides to wrap things up. I know we're getting towards our time. Some of the additional applications. So listed at the beginning was the goal of data and tools to support federal decision making. These data can be used for long-term planning and engineering, such as feasibility studies, smart planning within the core, design of coastal structures and flood protection features, and for stochastic design. Additionally, the data, the AEP values, like I've shown on some of the previous slides, can just be used for risk assessments and similar types of analyses. And those are easy enough just to grab that data and use that for your localized situation. Next slide, please. So here I wanted to just highlight some of the CHS data and applications, and these are, throughout our study area. I've been keeping track of a number of our SACS applications. These are just applications within the core, but there's a number of other, a lot of this other data has been out there a little bit longer, and there's been a number of studies, both regional studies and local studies that have used this data. So some of those are listed here within the South Atlantic, and specifically within the core. We've already begun using this data for some of our work in Puerto Rico and our San Juan Metro study and our Puerto Rico coastal study. We have an upcoming study or just kicked off a study in St. Johns County, Florida. And the CHS data will be used to develop storm suites and data that will drive cross-shore change models. Up in Camden County, Georgia, we're currently using this data as part of a risk assessment. So just taking those annual exceedance probability values, mapping them, and taking a look at resources and infrastructure that kind of falls within given AEP values. And there's other examples. Fort Sumter up in Charleston Harbor, we're using this for breakwater design. So using some of the hazard curve and information to help guide that breakwater design. We're also using it in some restoration, ecosystem restoration projects, including in Deer Island, Mississippi. So there's a number of studies throughout the Southeast that has already taken advantage of this data on the core side, and we know there'll be a number of studies and a large amount of work on the local side that will hopefully utilize this data set. Okay, next slide, please. Okay, and this is the last slide. I kind of alluded to some of this earlier. There was a question about FEMA. And as I mentioned, so the group at CHL, Norberto's group, they meet regularly with FEMA officials over this data and really all the CHS and FEMA data. They are currently working on a joint statement regarding the release of the CHS data throughout the Southeast. It's going to be very similar. They've had the same statements for the NACS and other data sets. That statement is actually on the desk of some FEMA official right now, waiting for approval. So that should be released in the very near future. So, some of the differences, one of the things I guess that's important to understand is the base flood elevations documented on FEMA firms include some components that are not included in the SACS or the CHS data. So that includes, the total water level is what's reported on the firm. That includes the still water elevation, which is what we're getting out of CHS, but it also has contributions from overland wave propagation, any potential impacts due to episodic dune erosion and wave runup. So the BFEs are usually not directly comparable to what is reported in SACS or in CHS, but they're, I should say they're not directly comparable, but, we can look at just the still water elevations. So that's what's presented here on the lower right for a gauge in San Juan with the FEMA data superimposed on the CHS data. And what's shown here is generally true. There are some localized differences because of the times the studies were done, when the studies are done, but generally the FEMA data falls within the confidence levels of the CHS data. You know, and there are certainly occasions where it doesn't, localized occasions. Typically that has to do with either model mesh resolution, the digital elevation model that went into the model mesh, or some differences in study methodology. For example, for the Florida Peninsula, some of the FEMA studies did not include exit-in storms, so they only included landfalling or bypassing storms, where the CHS data does include exit-in storms, so that, you know, affects the annual exceedance frequency data and how that's reported out. And the other data set that's out there and widely available is NOAA produces extreme water levels. Those are published by NOAA. So these are based on an extreme value analysis of observed water levels at their NOAA gauge locations, water level locations. So the methodologies between CHS and how NOAA derives these, they vary quite a bit. In general, the CHS results are much larger than the NOAA results, and this kind of goes back to that Hurricane Michael example in Mexico Beach, where the NOAA values are largely dependent on observed water levels at that location, where the CHS values, you know, account for the entire parameter space, and they account for events that have not yet happened at that location. So there are going to be, you know, large discrepancies between those data as reported out. So I think that covers everything, and this slide was kind of doesn't necessarily fit in with everything else, but it's important to hit on those differences. So I think we have just a few minutes left, but we can go ahead and take more questions.
Yep. So we have a couple different questions related to accessing the data and applications of the data. So from one stakeholder who is supporting an effort in Low Country, South Carolina. It's a plan for resilience measures adjacent to the local military bases. And so she's wondering if there's a way to obtain the SACS data in a shapefile format rather than the online file, or if there's a contact person to get in touch with. And just, I think, kind of generally, people are wondering how to get this data, how to use it locally.
Okay. So yeah, currently the data is just available online for, you know, if you have, I guess, a localized project, it's, you know, it should be just a few minute step to a few minutes to download the data for, you know, if you're looking in a relatively small area, you can select multiple save points at once, download all that data at once. If you're, you know, looking at the state level or something like that, then it gets to be a little more cumbersome. And, you know, at that point, I'm trying to think, I mean, we could probably figure out a different way to get the data. I guess it depends also on what data you're looking at and the application. So if you're looking just for like a risk assessment, you're looking at, you know, what is your you know, 1%, your you know, your 100-year, your 50-year, your 10-year water level, then that data is a lot easier, as those are discrete values. If you're looking to drive a numerical model and you need time series of data, then that's where, that's where the CHS website really comes in handy, because you can download all that time series, and it's much easier to kind of transfer that data, as opposed to, because that can add up to quite a bit of data. Time series for, hundreds or thousands of storms can get pretty large. So, I guess to circle back to the question, the website's probably the best source of data. If, you're having a lot of trouble on that, you can reach out to me, and or if you need, a larger area, and lassoing all those data points for a given state might not be the most efficient way. We can see if we can directly get you that data.
Great, thank you. And this is kind of along similar lines. What specific data that's part of this study, either currently or coming out in the future, would you recommend for local governments to use in development planning? And they're specifically talking about North Carolina, but I think this is applicable to everywhere.
Right. I would say it's probably the hazard curve information, the exceedance probability. So the peaks data and the time series data, that really gets into more design, I guess. Typically the time series data you're going to use to drive a different model. So either, a high resolution hydrodynamic model, or a cross-shore change model, or something like that, where if you're more interested in just kind of risk assessment and overlaying the data on your existing infrastructure, so to speak, or something like that, then it's really that annual exceedance frequency data, which is, all computed for a given save point. So really it would be, either in your local municipality, selecting the applicable save points in there, and just really mapping those, overlaying those with your areas of interest, and working with that type of data.
Perfect. And then kind of tying these together with the resolution questions from before, when the resolution is somewhat low, how can the SACS report and CHS be used to plan for infrastructure and building elevations within newly expanded floodplains and coastal areas?
Okay. Yeah, I guess that is, I'll have a somewhat similar response. If 30-meter resolution is, typically most of the models we use kind of break down at anything higher than, say, 10-meter resolution, at least for a lot of these studies. So 30 meters isn't, for a regional effort, I think is a pretty high resolution model. If you're interested in something beyond that, or more, higher res than that, that's where, again, you could take the results that are provided by CHS and in terms of the time series data and that, and then look into running something more high res, and then you would have to look into the probabilities. So the storm weights, which are available, you'd have to look at that data and kind of run your own joint probability analysis for the higher resolution results.
And I think we're running low on time here, so I'm gonna just grab maybe one or two more questions, and we will have these questions. We will be downloading them after the webinar, so we can look through them and reach out to people as needed. But one suggestion or question that we had was whether there'll be a presentation demonstrating how to use this data for some of the applications we've talked about here.
I don't, I mean, that's, we could probably arrange something, and I can, you know, maybe follow up with, so this data is, you know, somewhat new to us in the South Atlantic. I can probably follow up with some of the folks in the North Atlantic that have really been utilizing this data for 4 or 5 years now, to get a better idea of some of the, you know, applications that they've used it on. But we could, yeah, we can look into, you know, more of a, I guess, specialized talk just on applications.
Great. And I think with that, I'm going to move to the next slide so we can wrap up here. Let's see. And
Okay,
I believe, yep.
Lindsay, thank you so much. And Drew, I want to, on behalf of our whole team, I want to thank you for that great presentation. I know that there's a lot of interest in coastal hazard system. I appreciate the question regarding follow-up communications on applications and kind of doing some how-tos. I will say that some of the SAC's recommendations do include capitalizing on follow-on study opportunities to take the coastal hazard system out into the field and do some field training, do some training on how to apply these data. But as Drew mentioned as well, we've got a number of other follow-up opportunities as we move forward for additional webinars and such. So if there's a strong interest in that, we can kind of talk offline and see what we can do in terms of maybe providing a follow-on opportunity to walk through some data applications as examples for sure. Because we certainly want to ensure that not just coastal hazard system, but other South Atlantic coastal study technical products are useful to you. And if there are questions on how to apply those products, we'd like to be able to step up and assist in making sure that information gets out there. In terms of what we've got right in front of us, looking ahead, on this slide, we're indicating environmental technical report. We've got a suite, at least 3 technical reports that are getting very close to being finalized and going through those final legal and policy checks and being able to be posted. So between July and August, you please be checking our website because those will be posted. As I mentioned, we plan on releasing our draft report in October. We've got an internal milestone meeting with our agency leadership to officially get the thumbs up to move forward to release that draft report. Not coincidentally, our next scheduled quarterly webinar would normally occur in October. What we plan on doing, I don't want to say instead, but what we plan on doing in October is set up a series of workshops and coordination meetings, one in each state and territory, to roll out the SAC's draft report recommendations and findings on a state-by-state basis, as well as Puerto Rico and the U.S. Virgin Islands. So if you've got a particular, if you're a practitioner in a particular state, that's likely the workshop that you'd like to attend. We'll be working with our project managers in our districts to set those up, and what we'd like to do is ensure that when the draft report hits the street, you are all aware of how that report's organized to kind of facilitate your review, and also take that opportunity to extract some of the more powerful findings and recommendations and put those before you in October on a state and territory specific basis. In January, we'll be hosting a quarterly webinar focusing on the Tier 2 economic risk assessment. The SAC's GeoPortal does have a Tier 2 economic risk assessment dashboard that is live and is available for you to go into and take a look at this time That dashboard gives us some snapshots. You can drill in to any particular part of the study area that you're interested in and take a look at what estimated damages to infrastructure would likely be under certain scenarios under both existing conditions and conditions with sea level rise. That kind of gets to one of the SACS products that we hope supports your efforts on a local and a regional basis, try to get a better handle on risk and make informed development decisions. And then, of course, as we move into next year, August of 2022, we'll be looking to provide a final report up to our leadership in the Corps of Engineers for final approval. And of course, that final report should incorporate your feedback on the draft report and the feedback that we get through those workshops in October. Next slide. This is the contact information, again, for our team. Please feel free to reach out to any of us. Reach out to Drew for any questions, follow-on questions that you may have that you didn't get a chance to ask. As Lindsay indicated, Drew will try to get through the questions that we didn't get to and come up with answers to those questions. We can post those or most assuredly get those answers back to you all who actually posed those questions. We've got our engineering team members here within each of our district offices. So any specific questions on applications, please feel free to go ahead and reach out to those engineering team members, as well as our district project managers or our regional team. So with that, I'm going to thank everybody again for hanging in there with us today. I want to thank Drew again for his presentation and for everybody's interest and participation in this workshop. So thank you very much.
Thank you, Pam. Thank you, Drew. And thank you, everyone, for joining. We will be closing out the webinar in just a moment.